concentrate on two topics. One is the photonics and the other is plasmonics. Okay, these are two new fields. So for this, I'll use periodic structures. I'll explain what these are and how these are made, okay, and what are the challenges, and eventually why we are interested. Okay. So I'll begin with where we evolved over the last, say, 50, 60 years, and then what are the challenges for tomorrow. Tomorrow, since for 15, 20 years from now, we want to have devices which are better than today. For example, we use these pointers, we use the projector. Okay, how many of you do not use a mobile phone? So all these development, how many of you use internet, emails? Okay, almost most of you, I guess. Okay, so these are all developments over the last 60 years. Okay, if you look at the core of it, the main development which which made all these things possible, whether it talk about this pointer, or whether it talk about your mobile phone or your computer, everything is possible because of the development in the field of semiconductors. Okay. So coming from material science department, okay, that we study semiconductors. Okay. That's one of the things we will look at. Okay. One of the materials we will look at. Okay. So I will show you how we have evolved over the last 60 years. Okay. You see, this is the first generation computer. This is the very first computer which was made. It's called the electronic numerical integrator and calculator. Okay. All that it was fancy, all our mobiles do it, addition, subtraction, multiplication. That's all division. Okay. So all that is done in a small chip nowadays. Okay. But this was a room as big as this. So it's full of all these modules. It's made of 18,000 vacuum tubes and it consumes 150 kilowatt power. And it took 2 years to build it. This is the very first computer. Then a year later, transistor was invented. And it was invented at, when was it invented? Bell Labs. Okay. Bell Labs is art and so on, I think whatever you follow modern day science till 10 years ago or 5 years ago. So most of the development in today's world in terms of material science, semiconductors, modern devices. So there is a research leader who has some interaction or other with Bell Labs at some point or other in his life. Okay. So the transistor was invented in 1947, and after 7 years, the first transistor digital integrated computer was built. Okay. It has 1800 transistors and it has 10,000 germanium rectifiers. Forget about what they are. As I understand, many of you are from biology, zoology, mathematics and all that. So these are just some devices. So, and it used just 100 watt of power. Okay. Compared to 150 kilowatt, 100 watt power is 1000 times less power. Okay. And it's just, you can fit it in a corner. Compared to a room full of computer, okay, we have a one corner computer. So that's where the development was essentially governed by transistor, or the development in the field of semiconductors. Now we have the 4 to quad core processor. Okay, this was the last year something so taken. So can you imagine so this 1954 computer has 800 transistors and 10,000 germanium rectifiers. Can you guess how many transistors are there in today's Intel chip? A chip, it's 1 inch by 1 inch kind of, and about maybe 4 or 5 everything. So do you know how many transistors are in it? 5 years. Sorry? Millions. Okay, how many?
64 million.
64 million. Okay, I'll tell you. They have the million is order of magnitude, maybe we can say that, but it has 832 million transistors. Okay. That's 832 into 10 power 6 transistors in a 1 inch by 1 inch area. So we are able to squeeze so many transistors. Each transistor is like a switch. Okay. Whatever we are using to turn on and off, it takes some milliseconds kind of thing. Each transistor can work in nanoseconds or even faster, depending on the type of material and the geometry. So these are used essentially all our digital logic is essentially possible because of these transistors. Okay. Your AND or NAND gate, universal gates and all those things. For those who are from physics background, you will be learning about digital electronics and all that. Okay. So all this it's essentially physics. But then slowly once it attains its critical volume or density, whatever, so it has evolved into electronics. Today we have as a separate branch of science. Okay. So essentially what we are going towards is we want smaller devices and we want very efficient devices. We don't want to consume hundreds of watts. We want our mobiles which are essentially, we expect them to do everything. Okay. It has to take pictures, it has to take do the computing, it has to do our SMS, and actually making calls is only a bare minimum. We don't want this for making calls. We want to do everything else which a computer does. Okay. So we want this to be carried in our labs or knee top or whatever you call it, like palm top. Okay. So essentially we are going towards smaller devices and they all have to work. To be able to carry them, we need to work. We need them to work on single batteries. So we need them to be very power efficient. So that's one thing which is possible with semiconductors. The second aspect is, or the third aspect, first is the small size, second is power consumption, and the third is the speed. Okay. So the speed essentially the next slide. Okay. So you see that now we are working on optical networks. So it's essentially we are no longer using these huge bundles of copper cables. We are now moving towards a fiber. So essentially whatever data which this big bundle of copper can carry, it can be transmitted in a single fiber. That's because the optical fiber has a bandwidth of about 25 terabytes. In addition, the efficiency point of view, if you use copper repeaters, it's electrons which are involved. So the electrons are charged. So if you have high power electricity line going near your copper cable, so essentially all your the old telephone lines. Okay. So essentially there is a copper cable which is through which the voice data is sent. Okay. What happens is if you have a electrical line, okay, so these electrons essentially they interfere with the other electrons, which is our data, and the data is messed up. You can't understand. You just hear that sound or something like that. Okay, so nothing is audible. But if you use photons, if you use fibers, all these kinds of noises will be removed. Okay, and in addition, because of these interferences, you have to repeat signal. So essentially, you amplify your telephone voice data every few kilometers. Okay, or 3 times in 10 miles. Okay. But in case of a fiber, you just need to repeat it or amplify it just once in say 60 miles. So all these intermediate amplifiers, all these things are usually cost. Okay. So your cost of installation is coming down. Why we used to pay I don't know, when I was a kid, calling international call was prohibitively expensive. So we can't if I have to call US no way. But now it's easier to call from India to US than US to. That's the stage we are in. It's all because of the fiber network. The speed and the efficiency which is coming out it's making things cheaper. Okay. And this is possible because of replacing electrons with photons. The photons are, as you know, they travel at ultimate speed. Right? So there is no other matter we know of. Okay, people talk about thought and other things, but these are, we don't know how to use them or how to control them. Okay, we always think about something nice movie or something else, but we can't control them to do Actually, like what addressing or what I'm trying to motivate you towards is electronics is like the last century, the 21st century was completely governed by the field of electronics. So if you call 21st century as the century of electronics, for the future we are moving towards photons, using photons instead of electrons, because there are numerous advantages. So one example where photons have totally taken electronics out of picture is the communication, fiber network. So for future, can we replace the computers also with optical computing instead of using electrical currents or the electrons? Can we use photons? Can we use light beams to do our computing? Is it feasible? Is it possible? That's what we will look at. Okay. So if you look at the advantages, you can do like parallel computing.